The hidden life of the Milky Way. We live inside a galaxy so vast, so ancient, and so mysterious that even today, after centuries of observation, we still don't fully understand it. This is the Milky Way, our cosmic home, a swirling island of stars in a dark ocean of space. And although it's the only galaxy we can see from the inside, it remains one of the hardest to study. You might think astronomers would already know the basics: how many stars there are, what its exact shape is, or how it came to be. But even these simple questions remain puzzles. Current estimates place the number of stars somewhere between 100 billion and 400 billion. That's such a wide range that it's like trying to guess the population of Earth, but only being sure it's somewhere between 2 and 8 billion. The truth is, we're still not sure. The structure of the Milky Way is another riddle. For decades, scientists have debated whether our galaxy has two spiral arms, like a simple pinwheel, or four sprawling arms decorated with giant clouds of gas and star-forming nurseries. At the moment, the evidence leans toward four, but we don't yet have the definitive answer. Why is it so hard to see? Imagine standing inside a house and trying to describe the entire building without ever leaving your room. You can peek through the windows, but the walls block your view of the rest. That's exactly our problem. We live within the Milky Way's walls. Dense clouds of dust and gas obscure our view of the galactic plane, especially near the center, creating what astronomers call the zone of avoidance. Ordinary telescopes cannot peer through this, forcing scientists to turn to infrared light, radio waves, and X-rays to glimpse what's hidden behind the curtain. Enter Gaia, a mapmaker among the stars. To truly measure our galaxy, astronomers needed a revolutionary tool. That tool was the Gaia Space Observatory, launched by the European Space Agency in 2013. Gaia's mission was deceptively simple: to create the most detailed map of the Milky Way ever attempted. Over a decade, it made more than 3 trillion observations of stars, building a precise 3D atlas of 2 billion stellar objects. Gaia's secret weapon was parallax, the same principle you can test by holding up your finger and closing one eye, then the other. Your finger appears to jump compared to the background. Stars do the same when Earth moves from one side of the sun to the other. By carefully measuring these tiny shifts, often smaller than a hair's width seen from thousands of kilometers away, Gaia calculated distances with astonishing accuracy. But Gaia went further. Its billion-pixel camera and spectrometers measured not just position, but also the temperature, mass, chemical composition, and velocity of each star. It was like turning on the lights in a cosmic city, revealing not only where the inhabitants lived, but also how they moved, what they were made of, and even what their life stories might be. A galaxy with a violent appetite. Among Gaia's most shocking revelations was the discovery that the Milky Way is a cosmic cannibal. Our galaxy has not grown peacefully. Instead, it has survived by devouring its neighbors. Gaia uncovered a population of about 30,000 stars moving in the wrong direction compared to most others. These stars had unusual compositions and brightness, unlike the rest of the Milky Way. The only explanation? They were immigrants, the remnants of another galaxy that had collided with ours around 8 to 11 billion years ago. Astronomers named this long-lost galaxy Gaia Enceladus. And Gaia Enceladus was not alone. Other collisions have been identified too. The Sagittarius dwarf galaxy has smashed into us several times over the last 5 billion years, stripping away its stars and flinging them into long tidal streams across the sky. It may even have triggered the birth of the Sun about 4.6 billion years ago. A smaller system called Sequoia also merged with us, likely at the same time as Gaia Enceladus. In total, evidence suggests the Milky Way has swallowed at least 6 galaxies throughout its history, with Sagittarius still being actively consumed today. These galactic feasts shaped the Milky Way's very structure, giving it a thick central bulge and even its bar-like core, something seen in only about 2/3 of spiral galaxies. The Milky Way in motion. Gaia's data also lets us rewind and fast-forward the galaxy's history. By tracing the motions of billions of stars, astronomers can simulate what the Milky Way looked like billions of years ago, and what it will look like billions of years into the future. The stars around us are not fixed. They drift like currents in an ocean, sometimes spreading out, sometimes bunching together again in great waves called density waves, which help form the spiral arms. And far into the future, another colossal collision awaits. In about 4.5 billion years, our galaxy will merge with the Andromeda Galaxy. The night sky will be filled with streams of stars stretching across the heavens, and eventually the two giants will settle into a new elliptical galaxy nicknamed Milkomeda. Gaia's treasure chest. Gaia's contributions extend far beyond mapping stars and uncovering galactic cannibalism. It has charted the orbits of 150,000 asteroids in our solar system, revealing that hundreds have tiny moons. Identified over 1.3 million quasars, bright beacons of galaxies powered by supermassive black holes, some dating back to when the universe was just 1.5 billion years old. Discovered a massive black hole 33 times the mass of the Sun, only 2,000 light-years away, one of the largest stellar black holes ever found in the Milky Way. Provided evidence for thousands of binary star systems, and perhaps even hinted at undiscovered exoplanets, thanks to subtle stellar wobbles. The end of Gaia, and the next chapter. In early 2025, Gaia finally ran out of its fuel, tiny jets of cold gas that kept it steady at the second Lagrange point, 1.5 million kilometers from Earth. On March 27, 2025, the observatory powered down for the last time, but its legacy is far from over. Two more massive data releases are still scheduled. Data Release 4, 2026, 500 terabytes of ultra-precise measurements, including the largest catalog of binary stars ever assembled. Data Release 5, end of the 2020s, the complete treasure trove of Gaia's 10.5-year mission, containing every observation at the highest level of detail. And the story will not end there. Plans are already underway for a successor, Gaia NR, a near-infrared version of the telescope that could launch in the 2040s. Unlike its predecessor, Gaia NR would peer through the dust clouds that currently block our view, opening up an entirely new perspective of the galaxy. Our place in the galactic story. The Milky Way is more than just a backdrop to our lives. It is a dynamic, restless, ever-changing ecosystem of stars, planets, black holes, and cosmic debris. It has eaten galaxies, survived collisions, and given birth to billions of suns, including our own. Thanks to Gaia, we now know that our galaxy is not static or serene, but alive with motion, history, and future drama. We can trace the scars of ancient mergers, predict the spiral arms that cradle our solar system, and even glimpse the titanic fate that awaits us when Andromeda arrives. We are children of a galaxy built on collisions, survivors of a cosmic past we are only just beginning to understand. And though Gaia has fallen silent, the knowledge it left behind will echo for generations, guiding us closer to the ultimate question: what does it truly mean to live inside the Milky Way?